Hello everyone and welcome to this lecture. In this lecture, I'm going to walk you through the code that can be used to perform rotation, translation, and resizing. All right, so here is the photo source, all right, that we're going to be using to apply our code. So first, we're going to load all our libraries. So we imported OpenCV, NumPy, Matplotlib, and afterwards, we read the image. So our image is self-driving car.jpg, and the image as well, you can either download it through that link, or it's you will find it available in the course package as well. So here is our image, and we used OpenCV.image show to actually show our image. And let's take a look at it. Shift Enter. Here we go. So this is our image of a self-driving car showing, our LiDAR here on top, and looks good. And the next step is we're going to visualize the size of the image, so the width and height. We have done that before several times. Shift Enter, Shift Enter. So here we have 661 pixels by 1,000 almost pixels for the width. All right, let's go ahead and actually perform rotations. So as we discussed in the previous lecture, that we can perform rotation using cv2 dot get rotation matrix 2D. And what we could do here, we need to specify two things. We need to specify the center of rotation. So here I wanted to rotate the image at the actual center. That's why I specify width divided by 2 and height divided by 2. That will be kind of the center of rotation. The next step that we need to obviously specify the angle of rotation. How many degrees you wanted to rotate the image. So here we specify it's 45 degrees. And then here we specify as well if you wanted to perform rescaling. It's kind of you are rotating the image and you are, let's say, making it a little bit, let's say, smaller or a little bit maybe bigger and so on. So here we specify 0.4, and that should give us the M rotation matrix. Afterwards, we're going to use OpenCV.warp affine, which means we're going to perform an affine transformation, which means all the sides of the image are actually in parallel. We are going to maintain like how the sides of the image are parallel. So before in the original image and in the transformed image, both of them have the same kind of, all the sides of the image are maintained in a parallel format. If they are non-affine, then the output image, the sides won't be parallel anymore. Please, again, if you're a little bit confused, please go ahead and review the actual lecture where we covered a kind of a quick example that shows how we perform affine and non-affine transformations. So we're going to say, okay, OpenCV or cv2.warp affine. We're going to pass along our image, which is our original image here. And then we're going to use M rotation, which is our matrix that we defined before. And we're going to specify as well the width and height of the output image. And that should give us our rotated image. And then here we're going to simply use OpenCV to visualize or show our image. Shift Enter. All right, looks great. As you guys can see, this is simply our image. The three conclusions or three kind of observations we're going to get. First, the center of rotation was in the center of the image, which makes sense because that's what we specified here. We specified the center is width divided by 2 and height divided by 2. The next observation is that we rotated the image by 45-degree angle, which makes sense as well because here we specified 45 degrees. And the third observation is that the image has been rescaled. So it actually went a little bit smaller, as you guys can see here, compared to the original image. All right, so maybe let's go ahead and maybe try, let's say, instead of 45, let's make it 90 degrees. And maybe let's go ahead first, change it to 90. As you can see here, this is just changing the angle. As you guys can see here, instead of 45 becomes 90. What we could do here, we can maybe, let's say, change it from 0.4 to 0.7. So we do Shift Enter. As you guys can see, the image becomes larger. That means, yes, we kind of downside the image. However, the image is still like when we perform the rotation here, Okay, it's, yes, we rescaled a little bit because the dimensions of the width and height are different, right? So for example, if you, let's say, scale it and you make it, let's say 1, which is you maintain the actual size of the image, as you guys can see, because the width and height are different, when we rotate it by 90 degrees, we actually kind of crop the image. We lost data. That's why we wanted to rotate the image and maybe scale it down a little bit. Kind of, reduce the size, let's say to 0.5, for example, so we can actually rotate it and see the overall entire image as well. All right, maybe one quick change as well. Maybe instead of having width divided by 2, maybe width divided by 3, and that will change the center of rotation. So Shift Enter. As you guys can see here, we rotated around like somewhere in here, okay, compared to the center of the image. All right, let's go back, make it 2 by 2, and here we go. Looks great. Okay. The next step is that we're going to learn how can we perform translation or kind of move the image a little bit. As I mentioned in the lecture, that we're going to create a matrix, and this matrix, we're going to call it translation matrix, and we're going to specify 1, 0, and then what is the amount of distance that we need to shift in the X direction and in the Y direction. So Shift Enter, looks good. And then we're going to use, again, OpenCV warp affine. We're going to pass along our image, pass along our translation matrix, and we're going to specify as well the size of the output image. And that should give us our translated image. So here our translated image, we're going to show it, Shift Enter, here we go. So as you guys can see, we simply shifted our image to the right and to the bottom as well, because this is the X direction and this is our Y direction, because the origin is somewhere in here, right? So Shift Enter. And if you guys want to actually confirm that this size is 200 by 100, here I prefer to actually use matplotlib to image show, or to show the image, because it will show the image in the actual kind of, like a Jupyter notebook. So you can visualize as well the pixels too. As you guys can see here, we shifted to in the X direction by 200, which makes sense because we specified as 200. And we shifted in the Y direction by almost 100 because we specify the change in the Y is around 100. Okay, if you, let's say, change it, for example, to, let's say, 50, and maybe this one maybe to, let's say, 300, Shift Enter, Enter, Enter. Looks good. And here we go. As you guys can see, we shifted by around 250 and around, 300. As you guys can see here, this is 300. And we shifted by 50 down, as you guys can see. One quick observation is that the colors of the image are kind of messed up. Please don't panic, it's normal, we have discussed that before, because we used matplotlib or PLT with an image that we used or we loaded before using OpenCV. The order of the color of the channels is reversed, okay? So OpenCV just simply reverse the order of the channels. So it used BGR instead of RGB. So if you wanted to maintain the colors, load the image using OpenCV and plot it or show it using OpenCV as well. You shouldn't have an issue. But here we mixed them up. We use matplotlib. That's why you will find the colors have been messed up a little bit. Excuse me. The last step we're going to use here is how to perform resizing. So you want to take the image and resize it. So we're going to specify, okay, I need to, let's say, resize the X by 0.75 and resize the Y by 0.75 and use cv2.resize. That should resize the image. And we're going to specify the interpolation. If you guys recall, we had a series of different kind of interpolations. We have cubic interpolations, we have linear interpolations, and so on. Here we just use cubic. And that would just kind of interpolate the values of the pixels when we are performing resizing. So Shift Enter, looks great. So here we were able to actually resize the image. All right. And if you, let's say, change it to, let's say, 0.5 and 0.5, Shift Enter, you guys can see that the image have been resized, went a little bit smaller, and we have been able as well to maintain kind of, kind of the resolution as well of the image. However, if you try to resize it and change it maybe a little bit bigger, for example, resize it, let's say to, for instance, 2, and let's say 2, Shift Enter. So you guys can see here, we're able to as well because we added additional pixels, so we need to perform interpolations between the pixels. So you find that the actual image, the quality of the image has not been deteriorated that much. Okay, again, we use cubic interpolation here, and maybe if we change it, for example, to let's say 4x4, enter, here we go. So you guys can see, unfortunately, I can't even visualize the image here because it's huge. So you guys can see this kind of, like how we resize the image. And obviously the quality of the image will be deteriorated a little bit because we need to add kind of additional pixels somewhere, right? So that's why we perform intercubic or cubic interpolations between the pixels. All right, that's all what I have for this lecture. I hope you guys enjoyed it. Let's recap what we have done in this lecture. This lecture we have been able to learn how can we perform rotation, translation, and resizing using OpenCV. We loaded the image, we specify the dimensions. Here we use get rotation matrix 2D. We specify the center of rotation. We specify how many degrees, and we specify if we wanted to actually change the size or resize the image as well. So it's kind of a combo. You're doing rotation and resizing as well. That should give us the M rotation matrix. We pass it along here, and we pass along the image, and we specify the output dimensions. And we're able to use warp affine to actually rotate our image. We're able to use translation by creating our translation matrix, specifying the number of pixels we wanted to translate in the X and Y, and then we use warp affine to perform the translation as well. As you guys can see here, we shifted the image by, let's say, 300 pixels and 50 pixels down. We learned as well how can we perform resizing by specifying or using OpenCV.resize, given the image, specifying the interpolation, and specifying how are you going to downsize it or resize it smaller or bigger using fx and fy, and we're able to visualize the image as well. And that's all what I have for this lecture. I hope you guys enjoyed it, and see you guys in future lectures.